Hello and welcome back. So in this video we are going to discuss the third angle property, and it is about the angles in the same segment. It states angle in the same segment are all equal. First of all, we know what is a segment. Basically, a chord divides a circle into two segments. Like if I join the 2 points on the circumference A and B, so this will be a chord AB, and it is basically dividing the circle into two segments. One is the minor segment, other is the major segment. So uh, if I talk about the arc AXB over here, so there is a segment opposite to it. So any angle in this segment will be the same. Like if I subtend an angle over here in this segment, its endpoint must be the same points A and B, and it is formed at any position, it is the same angle. Like if it is formed at the position P over here, suppose here is the point Q and here is the point R, so it is same everywhere in the same segment. That is why we call it angle in the same segment are all equal. Like these angle are all equal. If I say one of the angle is x, then all other angles are also x. So here is the diagram. It is abbreviated as angles in the same segment, and in the diagram we can see that here we have a chord AB, and here are the two angles APB and AQB, and they are both equal. So let us move to the practice now question, where here we have a practice now 8, and here the two parts of this one. First is, in this figure, A, B, C and D are points on the circumference of a circle. We can see these points on the first diagram, A, B, C and D on the circumference. Given that AC and BD intersect at X, angle BAC is equal to 44 degrees, ACD is 25 degree. Find the angle CBD, ABX and CXB. So first, the two given angles are already located at the like point C and point A over here, 25 and 44 respectively. First, in order to find the angle CDB, so angle CDB is formed over here, and in order to figure out this angle, first see that this is angle in the same segment as the angle 44. If I like want to uh, figure out which arc is subtending this angle, that is same arc CB which is subtending the angle CDB. So the angle CDB equals 44, and it is because of angle in the same segment are equal. Then ABX, as we can see, the angle ABX lie over here, and the angle ABX is in the same segment as ACD, because ABX basically equals ABD, and this is angle in the same segment as ACD, and we know ACD angle is 25, so basically ABX is also 25 degrees. So angle over here, it is also 25 degrees. So in order to figure out the angle at the circumference, first we find that which arc is subtending that angle, and is there any other angle subtended by the same arc. These are the angle which lie in the same segment and they are equal. Next we have to figure out the angle CXB, and we see CXB is the angle over here. So in order to figure out this angle, let us first clear the previous data. So we are to find CXB, which is the angle over here, and we know that the angle at position D, the CDB angle, it was 44 degrees. So we can use the uh, triangle property that exterior angle of a triangle equals the sum of two opposite interior angles. As we see the angle CBX, it is basic CXB, sorry, it is basically exterior angle of the triangle CXD, and it must equal angle the sum of angle XDC and the angle XCD. And we already know the value of these two angles, they are 44 and 25. So when we add up these two, the value of angle CXB shall become 69 degree. So that was the first part of this practice. Now, so in second we can see it states the figure A, P, B and R are points on the circumference of a circle with center O. Here is the center O. Here are the points A and B and P and R. It is given that AB is the diameter of the circle as it is passing to the center O. APQ and RBQ are the straight line. Find angle BPR, and angle BPR is located over here. It is part of the triangle BPR and triangle RQP as well. So first of all, we are given an angle over here. This angle is 45 degrees, and there is another angle over here. These two angles lie in the same segment. As we can trace that these two angles are subtended by the same arc BP. So this angle over here is also 45 degree because angle in the same segment are equal. So now as we know that AB is the diameter, so angle over here at position P must be a right angle, because angle in a semicircle is always a right angle. So angle APB will be a right angle, 90-degree angle. So because the unknown angle is basically part of this angle, 90 degree, so we can discuss it like the angle adjacent to it is also 90 degree because it is a straight line. So I'm going to use this triangle QRP to find the value of our required angle. As we know, the angle over here, it is 25 degree at position Q. At position R, we know it is 45 degrees, and at position P, we know it is basically 90 plus one part of this angle is 90 degree, and the other part is the unknown which we need to figure out. Like if I want to name it as x, it will be 90 plus x. So in this triangle, we know the sum of angles must be 180 degrees. So it will be 25 plus 45 plus 90 plus x, which equals 180 degrees. These are the three angles of the triangle QPR. So x must be 180 minus the sum of these three angles, which are uh, 25, 45 and 90, and that is 160 degree. And after we subtract it from 180, x becomes 20 degree. Like the angle we needed, the angle BPR is 20 degrees. That was the unknown in second part. We can also solve it by using some other technique. So this was the third angle property, that angles in the same segment are all equal. and in coming video we are going to discuss the next circle angle property and its examples.